Hello everyone, I am Anjan this side. We are going to discuss about um, the generative AI course of Kaggle x Google. So my project is on AI therapist, a generative AI powered mental health assistant. This is a capstone project, and my problem statement is mental health challenges are on the rise globally, and access to timely personalized support is often limited. People struggle to track their emotional state, access reliable mental health resources, or find someone to talk, especially during critical moments. What happens these days, we some people, so they are mentally challenging some facing some challenges which are arising globally. So what happens is, uh, some are introverts, some are extroverts. Some people get people to talk with, and some people don't get to people to talk with. So personal support is often limited, and people struggle to track their emotional state, as they will be having multiple emotions to track, and people struggle for that and emotional state. So and often people do find someone to talk. Some people don't find someone to talk, and especially during the critical moments where some people can share, some people cannot share. So for that, the solution is AI therapist, is Google generative AI powered virtual assistant that help users to track mood, emotional well-being at via a text and audio input. So and log therapy style journal entries and structured sessions. We are having a RAG, retrieval augmented generation, for trusted mental health resources, for to detect emotional crisis and provide emergency grounding assistant. So generative AI capabilities demonstrated. So we are using few short prompting, structured output JSON or markdown summaries, audio and text understanding, RAG, grounding and context based assistance. Okay, coming to the first content, we are having AI mood tracker text based. So for the objective is casual text describing how they feel. People, for how this AI mood tracker is used, where we give an input, and the Gemini, what we are having the model, will give the output like that. So first I will start the session. It's gone so well. Okay, coming up to next, we are having a basic transformer pipeline and a default model. We will load the sentiment analysis pipeline and then the sample input, and we will get the sentiment result. Based on that, we will get a mood analysis, a sample text based input and output. These warnings we can ignore. And this is what we get. So here config.json is loaded, model.safetensors loaded, vocab.txt loaded. Then this is what we get, a mood analysis as. So here we have put user input as, I have been feeling anxious and unmotivated lately. That is a sad one, or we can say a negative mood. So this mood analysis, we got label negative and score almost 99.6%. Then we will integrate Gemini model with this one. So we are calling import Google Generative AI as GenAI. Then we list the model lists. So we have got this much. So and we go for the suitable model for this project. So here what the important thing is, first you need to have a secrets section where, so actually what we have here, we have a secrets API key in the secret section in the Kaggle provided. We can get the API from the Google Studio, and we are loading that API key into the API key variable, and we are calling that. Then we are testing the model. What we have got here is the Gemini 1.5 Pro, um, which is um, which is better than the Gemini 2.0, um, which is which gives better reasoning than 2.0, which is 2.0 is fast, but not like precise when compared to Gemini 1.5 Pro. So we have to 1.1.5 Pro. Then we come to the show time, for which we have the model loaded. Then we have the user input as upset. Then we are having a prompt, you are kind and empathetic AI therapist for the Google AI 1.5 Pro. We are telling that model to give like this input, like this output. Then we have the mood data and the fallback data. Let's see what it will give. Voila, what we are having is Gemini mood analysis. So emotion, we are having a sad. What you have, the word upset given to the model. We have got the emotion as sad. Explanation, it will give us the word upset indicates a general. This is the basic thing what we can work with the AI model. So next we will go with the AI therapist, a generative AI powered mental health assistant, audio mood detection, audio based. Then the objective is to emotion detection from the audio input. So accept an audio journal input, extract meaningful acoustic features, then return the results in the structured JSON model. So uh, we have taken the dataset from this one, and we can see the dataset here. We can see the dataset here. What we are having, I have this emotional speech audio and the tornado emotional speech set, and my testing recordings. So coming aside, so we can proceed. So this is the OpenAI Whisper library we can install for audio to text transformation or audio to text conversion and output receiver. So this takes a while. So we have completed with the Whisper model library download. So next we head into the audio to text module. So here we have dataset path, then emotion map, neutral, calm, happy, sad, everything, then file paths. So then this for loop for the processing of the processing, and then getting the each the file of the audios, then converting it to data frame. Then we will see the total samples we get. So the total samples we get 2880, and then we make a rainforest model with training these samples. So we have NumPy, Librosa library is to uh, convert that extract that features from the audio. Then MFCC, then Chroma Centroid. So are the uh, what we can say functions in the Librosa. Then we can go ahead and do that. Then go for the features and labels. This one. So this one takes a lot of time to build this one. So okay, we are back with the feature matrix with the shape of 2880 and 26, and the label shape is 2880. So we can go with the feature saving and label to the disk. So features and labels saved successfully. So then load pre-processed features and labels. So I loaded that one. So we are going to use the label encoder to convert that features into array, and train test split to split the data. So we're having the training set and testing set, and the classes angry, calm, and the rest. And we are having random forest and classification report accuracy score. Okay. Okay, we got the accuracy with 93%, and the classification report. Everything is nearly 90 and above 90. So we can save that model and the label encoder, then load it. Then here um, we will be having we will be predicting the emotion here. So this is my recorded audio. We can test with this. So I recorded with an emotion of happy. So the audio predicted with the predicted emotion as a happy. Then here my second output. The predicted emotion is happy. Then we can see the classes. The happy is having 29%, and we can have a graph here. So and we can generate a audio graph waveform, then a heat map. Then we can now go to this. What does this do means? So this we can see here. We are integrating a Gemini model for this, which transcript and predict the emotional state from the audio analysis and provide a gentle support reflection. And then transcript, then it will predict the emotion probability, mood score. Then it will log the report in a JSON model. So we can go ahead and run it. So it loaded a model. Okay, sorry for that. Yeah, this successfully ran, and we can see here we got the JSON format logging this file is one, and we got the Gemini analysis that I hear you saying say the word back, that is in the tone of a angry one. So this is having a 33% angry, and it gives some suggestions, some possible things to do, uh, and says focus on clearly communicating with your needs and things, and some motivational words, and the session is logged. Then we can see that logged in the output output file of the Kaggle, output folder of the Kaggle. We can see here we got the session log, then the encoder pickle saved model, then the random forest model, then the audio features label. So we can get back into this the audio to text and the report is completed. We can go with the rag model, rag with the text input and output. So what here, it's this in this one we get a weekly growth session and some suggestions. So sample group input we are having with the Gemini model. We can push that group inputs rag in context. With that, Gemini model will predict the report and analysis. So we have group input and Gemini prompt. Here we are having a group therapy check-in sessions, and the group member group input and the rag context, it is taking that, and it will, the task is to respond with the emotional understanding, personalized suggestions and general question for the participant to reflect on further and keep your tone supportive and warm, like that. So we are giving that Gemini prompt and print the response text. So here we got, it sounds like you are experiencing a real dip in your energy and motivation this week. So these are the uh, how we can work with the Gemini model really very well and excellently. This is the multi-turn capability. So here we are going to generate a Gemini multi-turn response with this same prompt and user reply. So what we have here, it will give a reflection, then the grounding suggestion, then the reflection prompt. So then we go to the weekly growth log, and in the JSON file, and logging the this one successfully. And then this rag will be finished. Then the crisis alert and the suicide prevention prompt. Here what is the use of this one is, when a person is happy, it will log as a crisis, not log as a happy mood and a stable mood. If any like angry or depressed, sad with the high high probability, it will crisis alert, then log the JSON and alert, like that. So we have voice emotion classification, audio input emergency. Then let's get into it. So crisis alert, suicide prevention prompt. We got the libraries job label libros and numpy. So let's go into then emotion model. We go for the uh, random forest model, then the label encoder models. Then predict emotions, probability classes and emotion probabilities. Then here, detect emotion crisis. What we are having is we are having the extract audio features, predict emotion crisis detection, then log or respond. According to this one, the what we are getting the output will be based on this one. So then go ahead. Then we will go for 30%. If any angry, fearful and distress is more than 30%, we will go to report that crisis alert. So what I have selected is the angry one, angry audio. So we are having a successfully crisis alert trigger. Timestamp, it will a timestamp and crisis emotion angry probability 30%, and status like this, and Unicode with that crisis alert trigger like that. If that is happy, then it will say no crisis detected, emotional probability like this, happy 30%, like that. So thank you. This is what my project was with the capstone project. So the conclusion, the key highlights: we gone through emotion detection, voice using ML, text-based mood tracking with grounding, Gemini-powered reflections and suggestions, crisis alert module for emergency detection, weekly growth sessions for long-term well-being. By integrating with these, I conclude this session and project. So if you have any doubts, questions related to this project, you can get into touch with me. So these GitHub, you can reach out with my LinkedIn, email. So thank you for exploring this project. Thank you, Anadol.